Welcome to our next video. We're talking about sampling, we're talking about hypothesis testing. There are different steps in hypothesis testing and we want to show it. We want to show those steps talking about a test concerning a standard deviation or a variance. So, we want to show that the standard deviation is smaller than 0.08 meters. Still concerning the sample I talked about in different videos, Parisian population, we take, say, 51 Parisians as a sample and we ask them about their body size. So we measure the average value, we measure the arithmetic mean, we measure the standard deviation of the sample, and we say that let there be a significance level of 5%. Now, the very important question, and the first question that needs to be answered in detail, is the one, do we have to choose this one or do we have to choose one of those ones? A two-sided test or a one-sided test? That's important to know first. And if there's a mistake, the rest is in mistake. Okay, we want to show that the standard deviation is smaller than this value. Now, if you want to show something, put it into the alternative hypothesis. If you want to reject something, put it into the null hypothesis. That's the important difference. Reject something, put it here. Accept something, put it here. That's important to know. Accept, alternative. Both words are spelled with A. Good. Which means that since we want to show that the standard deviation is smaller than 0.08, what would you say? Is it first, second, or third? Yes, you answer the question. Yes, you. Go ahead. I can hear it. I can hear it. Yes. Third one. Third alternative, which is true because we want to show, we want to positively show that the standard deviation is inferior to 0.08 or that the variance is inferior to 0.08 square. So this is what we need to do. We need to look at this formulation of the null and this one of the alternative hypothesis. Okay, that was the first step, stating hypothesis. The second one, identifying the test statistic. This is the test statistic that holds true when talking about a test concerning the standard deviation, a test concerning the variance of one sample of one population. The appropriate distribution is a chi-square distribution. So you have to look it up first, what's the appropriate test statistics and what's the appropriate distribution of the test statistic. Specifying the significance level, as I said already, 5%. The decision rule. Now the decision rule states the following. If the test statistic is inferior to the value that you can look or that you have to look up in the right table, in the right distribution, if it is inferior, you will reject the null. Right? If it is inferior, you reject the null. And this depends on the formulation. It depends on whether you chose step or the alternative 3 or 2 or 1. So look it up carefully in your textbook. There are large differences between those types of tests. So here, what are we doing right now? Where are we? Stating the decision rule. Okay, calculating the test statistic. The test statistic goes this way, and we just put in the values. 51 was the sample size, minus 1 times the variance of the sample divided by the value that we want to show or that we want to reject, square, because you have to distinguish again between the standard deviation and the variance. Okay. And keep this in mind, the difference between the Latin letter and the Greek letter. The Latin letter, which means the S, that's a Latin letter, whereas this one is a Greek letter. They're both pronounced z, right? Okay, but there's a large difference. The Greek letters always indicate the real value, the population value. So the Greek letters are somewhat superior to the Latin letters in statistics. In statistics, the Greek letters indicate the real value, the population value, but the Latin letter indicates the sample value only. So this way, Greek letters are superior to Latin letters in statistics. Okay, and we get the result of 175.78 as the value as the result of the test statistic. Now, as I said, if this value was inferior to that value, and you need to look it up. Better you do it now. Did you do it? Try to stop the film now and just look it up. Okay, I could see you did it. If that value was inferior to that one, we'd have to reject the null hypothesis. Since it's not inferior, since it is superior, since it's larger, we must not reject the null hypothesis. We do not reject the null hypothesis, which is our statistical decision. Our statistical decision now is we do not reject the null hypothesis. Then, check the possible errors. There are two possible errors, and one and only one can be made. It is either type 1 or it is type 2. And here, if we do not reject the null, it is no longer type 1 that holds true, that could possibly be true. It's only type 2. It's only type 2, not rejecting the null hypothesis, although the alternative hypothesis is right and the null hypothesis is wrong. This could be possible. Keeping this in mind, having made the statistical decision, we now need to make the economic decision that is at the end of this process here. So that was a large example of a hypothesis test concerning one variance in one population. That's it for now. Thank you for watching.